Another example, a 1 kilogram cart is rolling 2 meters per second as it rolls into a spring. The spring has a spring constant of 100 newtons per meter of stretch, or compression in this case. It is a spring that will compress and not stretch. During the collision, how much will the spring compress? Dx, that is a delta x. Here's a picture beforehand, and in this situation, first of all, our system would be the spring and the cart. We'll assume there's no significant dissipated energy once again. The spring is not compressed, so there is no elastic potential energy. The zero level presumably is the ground here, and so there's no gravitational potential energy. All the energy is stored in the motion of the cart, which is kinetic energy. No energy comes into or leaves the system, and the car runs into the spring, it compresses it and comes to a stop for an instant, and we will have elastic potential energy. There's no gravitational potential energy. Velocity is zero, no kinetic, and we're assuming no dissipated. So 100% of that kinetic energy is transferred into elastic potential energy. So to solve for the displacement of the spring, how much it compressed, we're saying that kinetic energy to start equals that elastic potential energy at the instant the cart has come to a stop, or 1/2 mv squared equals 1/2 spring constant times the compression, the change in position of the spring, and that's squared here. We want to solve for delta x, so I'll notice that the 1/2 will cancel out, and I'll divide through by the spring constant, and what I'll have is delta x squared remains equals mass times velocity squared divided by the spring constant. So delta x, or the compression of the spring, equals the square root of the mass of the cart, which is 1 kilogram, times the velocity, which is 2 meters per second squared, but we're going to square that, divide all that by the spring constant, which is 100. That's all under the square root sign, and that equals the square root of 4 over 100, or 0.04, and that equals 0.2, and the units will be meters, or about 20 centimeters of compression when that cart collides with the spring.